Hello, you're welcome to IDC Learning Center YouTube channel. For this video, we'll be looking at physics Jamb past questions and answers that will help you prepare for Jamb 2022. Let's look at the first question here. Which of the following could be effectively used to reduce friction? Is it A, kerosene, grease, water, or petrol? The right answer is B, which is grease. Question 2. What is the least possible error encountered when taking measurement with a meter rule? Well, the right answer is 0.5 millimeters, which is C. So it is not 0.1 mm, 1.0, neither is it 0.2 millimeters. Question 3. A quantity which requires magnitude and direction to be specified is A, temperature, B, distance, C, displacement, D, mass. The right answer is displacement, which is C. Now, displacement is the rate of distance measured in a specific direction. So, that's why that is the right answer. Question 4. I, electrical potential. 2, torque. 3, kinetic energy. 4, momentum. Which of the quantities listed are vectors? The right answer is 2 and 4, which is A. Okay? Now, a vector is any quantity which has direction as well as magnitude, such as displacement, velocity, acceleration, force, momentum, torque, and so many others. So, for this question, momentum and torque have both magnitude and direction. Therefore, they are vector quantities. Question 5. Which type of motion do the wheels of a moving car undergo? Is it A, vibratory and translational motion, B, random and translational motion, C, rotational and oscillatory motion, okay, this M shouldn't be here, D, translational and rotational motion. Now the right answer is translational and rotational motion, which is D. For a car to move from one position to another, the wheel of a car must rotate and translate to a new position. Question 6. A car accelerates uniformly from rest at 3 meters per second square. Its velocity after traveling a distance of 24 meters is A, 12 meters per second, B, 144 meters per second, C, 72 meters per second, D, 36 meters per second. In this question, the initial velocity, which is u, equal to 0 meter per second. The acceleration has been given in the question. From rest means 0, but acceleration has been given as 3 meters per second square. Okay? The distance, let's represent it with x, has been given as 24. Look at the distance of 24 meters. 24 meters. Find velocity. Can use this formula. V square equal to u square plus 2as. But since the initial velocity is 0, everything we have here will be 0. So, we are going to be left with v squared equal to 2 times acceleration times x, which is the distance. So, v squared equal to 2 times acceleration, 3, distance, 24. V squared equal to 2 times 3 is 6. 6 times 24 will give me 144. To find the final velocity, we need to make v stand alone. To do that, we look for the square root of both sides. Square both sides. So this square breaks this square root. V stands on its own now. Square root of 144 is 12 meters per second. So the answer, as you can see on the board, is A. Question 7. Calculate the escape velocity of a satellite launched from the Earth's surface if the radius of the Earth is 6.4 times 10 raised to the power 6 meters. Okay, we have option A, 25.3 kilometers per second, B, 4.2 kilometers per second, C, 4.0 kilometers per second, D, 11.3 kilometers per second. Escape velocity, okay, escape velocity equal to the square root of 2 times acceleration due to gravity times the radius of the Earth. Okay, this is the formula for calculating escape velocity. Now, escape velocity will give us 2 times acceleration due to gravity is always 10 meters per second. It's a constant. Alright, so the G here will be 10. The radius of the Earth has been given as 6.4 times 10 raised to the power 6 meters. Alright, now I want you to use your calculator to multiply this through. Okay, so if you multiply through, it's going to give you 128 million. Just take note of the formula. And the square root of 128 million will give us 11313.71 meter per second. What we have here, answer is in meters. Don't forget, meters per second. And in the options, what we have are in kilometers per second. So we have to change this to kilometers per second. To do that, we divide through by 1000. Okay, dividing by 1000 from the decimal point, we count 3 backward. 1, 2, 3. Our final answer will be 11. Look at where the decimal came to, 11.3 kilometers per second. Is the final answer. And the right option will be D. Okay, question 8. An object of weight 80 kg on Earth is taken to a planet where the acceleration due to gravity is 1/3 of the value on Earth. The weight of the object on a planet is A, 48 Newton, B, 12 Newton, C, 27 Newton, D, 36 Newton. Gravity is always 10 meters per second squared. So, the weight on planet, they ask us to find the weight of the object on the planet. Weight of the object on the planet, let it be WB, equal to weight, take note of this formula, weight on Earth divided by force of gravity on Earth. Force of G on Earth. That's not all. Now, times force of gravity on the planet. Okay? Force of gravity on the planet. I'm just trying to abbreviate. So, times the force of gravity on planet. So, the weight of the object on the planet will give me. Now, remember I said force of gravity on Earth is always 10 meters per second squared. So, force of gravity on the planet, an object of weight 80 kg, weight on Earth, let's start with that. This will give me 80 divide by force of gravity on Earth is always 10 meter. Remember, force of gravity on Earth is a constant, 10 meter per second square. So we divide this by 10. Now, times force of gravity on planet. In the question, the force of gravity on planet is 1/3 of the value of the Earth. So this will be 1/3 times 10. Okay, so this same thing as 80/10 times 1 times 10 is 10, 10/3. This 10 cancels this 10. I'll be left with 80 divided by 3. So this will give me 26.667 Newton, which is approximately 27 as a whole number, 27 Newton. So the right answer is C, which is 27. Okay, the way I approximated, since this is more than 5, call it 1, add it to the 6, it will become 7, that's 27. Question 9. One of the conditions necessary for an object to be in equilibrium when acted upon by a number of parallel forces is that the vector sum of the forces is A, average, B, 0, C, negative, D, positive. For this question, the right answer is B, 0. Okay? The algebraic sum of the movements of all the forces about any point is 0 when those forces are in equilibrium. That is why I picked B as my answer. Question 10. An object of mass 20 kg is released from a height of 10 meters above the ground level. The kinetic energy of the object just before it hits the ground is A, 200 joules, B, 4000 joules, C, 2000 joules, D, 500 joules. Kinetic energy equal to mass times gravity times height. So this will give me the mass here is 20 times acceleration due to gravity is 10. It's always 10 meters per second square. It's a constant. Take note of that. I've said that earlier. Okay? Times the height, which has been given as 10 meters in the question. So, my answer will be 2000 joules, which is C. Question 11. A machine whose efficiency is 75% is used to lift a load of 1000 newtons. Calculate the effort put into the machine if it has a velocity ratio of 4. A, 343.32 newtons. B, 233.33 newtons. C, 333.33 newtons. D, 334.33 newtons. Efficiency of a machine, E, equal to mechanical advantage divided by velocity ratio times 100%. That's the formula you need to know. I want you to also know that mechanical advantage equal to load over effort. Okay? Now, efficiency in this case equal to, since mechanical advantage is load over effort, replace the mechanical advantage with the load divided by effort. So the load up, bring the effort down, will now have velocity ratio times the effort. This one I brought it down from mechanical advantage. Okay? Okay? Now times 100%. Efficiency was given in this question. Efficiency was given as 75%. So 75 equal to the load, which is 1000. Now divide by velocity ratio, which is 4, times the effort, which we don't know, times 100%. Okay? Now, make this effort the subject of the formula. Cross multiply. So, you have 75 times 4 times E equal to 1 times 100. If you cross multiply, 1000 times 100 will give us 100,000. To get the effort, you now divide both sides by 75 times 4. Divide this side by 75 times 4. This cancels this. So effort stands on its own. Now, punch in your calculator 75 times 4. Your answer, use it to divide 100,000. You are going to get 333.33 Newton. So, that's my answer. The right answer is C, 333.33 Newton. Question 12. A wheel and an axle is used to raise a load whose weight is 800 Newton when an effort of 250 Newton is applied. If the radii of the wheel and axle are 100 millimeters and 200 millimeters respectively, the efficiency of the machine is A, 90%, B, 80%, C, 85%, D, 87%. To calculate efficiency, that's what they want us to do, right? We need to know the velocity ratio and the mechanical advantage before we can do that. Velocity ratio on its own is distance moved by the effort divided by distance moved by the load. So it's going to be 800 millimeters divided by 200 millimeters. So 800 divided by 200 will give us the velocity ratio, which is 4. The mechanical advantage now is load divided by effort. I said it earlier. The load here is 800. Look at it here, 800 newtons. Divided by the effort, which is 250 newtons. Okay? So 0 cancels 0. 80 divided by 25 will give me 3.2. Now I have the velocity ratio, the value, and the mechanical advantage. I can now solve for efficiency. Since efficiency is mechanical advantage divided by velocity ratio times 100, efficiency will give me mechanical advantage 3.2 divided by velocity ratio 4 times 100 over 1. Okay, so 4 here 1, 4 into 100 is 25. Efficiency 3.2 times 25 will give me 80%. The right answer is B. Question 13. A force of 500 Newton is applied to a steel wheel of cross section. A force of 500 Newton is applied to a steel wire of cross-sectional area 0.2 meters squared. The tensile stress is A. Now we have the options. Tensile stress equal to force divided by area. Force has been given as 500 Newton. The area is 0.2. Make the denominator a whole number, move the decimal ones and add 0. So we now have 5,000 divided by 2. Or you can punch it straight into your calculator, it's same thing. The answer will be 2,500. Now express 2,500 as is in standard form. That's you count from here 1, 2, 3. So it will be 2.5 since I counted 3 places times 10 raised to power 3 Newton per meter square. Okay, so this is the answer. And the right option is D, 2.5 times 10 raised to power 3 Newton per meter square. Question 14. What is the equivalent of 20 Kelvin in Celsius K? The Celsius and Kelvin's K are related by this equation. Temperature equal to 273 plus theta. In this equation, this theta represents temperature in degrees Celsius. Take note of that. That's what this theta represents. Why this T represents temperature in Kelvin? Why this is temperature in degrees Celsius? Therefore, the equivalent of 20 K will be 273 plus temperature in Celsius K, which is 20. My answer will be 293 degrees Celsius, which is B. Question 15. A glass bottle of initial volume 2 times 10 raised to power 4 centimeter cube is heated from 20 degrees Celsius to 50 degrees Celsius. If the linear expansivity of glass is 9 times 10 raised to power minus 6 per Kelvin per K, the volume of the bottle at 50 degrees Celsius is what? Okay. Cubic expansivity, which is what this symbol, equal to final volume minus initial volume divided by initial volume bracket change of temperature, which is same thing as final temperature minus initial temperature. Take note of that. Now, the cubic of volume expansivity, which is this is the cubic of volume expansivity, and linear expansivity, this linear expansivity, are related as this. So volume or cubic expansivity equal to 3 times linear expansivity. Take note of that. Therefore, this cubic or volume expansivity equal to 3 times the linear expansivity was given as this times 9 times 10 raised to power minus 6. Okay? By substitution now, substitute this into this formula. This volume expansivity, which I have here, replace it here. We have 3 times 9 times 10 raised to power minus 6 equal to the final volume V2 minus the initial volume was given here. The volume, look at it here, 2 times 10 raised to power 4. Now divide by, still on the formula, initial volume V1, which is 2 times 10 raised to power 4, bracket change of temperature from 20 degrees Celsius to 50 degrees Celsius will give us 50 minus 20. Okay? Now, make V2 the subject of the formula. Let this be over 1. Cross multiply. If you cross multiply, you are going to have V2 minus 2 times 10 raised to power 4. Okay, let me just read V2 minus 2 times 10 raised to power 4 equal to, now, this times this. 3 times 9 times 10 raised to power minus 6 times 2 times 10 raised to power 4 times 50 minus 20 is 30. Hope that is clear. Now, to get V2, okay, you have to multiply everything here and divide them by this. So V2, if you do that, you get 20016.2 centimeter cube as your answer. Please take note of that. You can go back a bit and just follow the instruction the way I've said you should do. All right, now let's go to question. Okay, let me pick the right answer first. 20016.2, that's A. Question 16. The question says, the quantity of heat needed to raise the temperature of a body by 1 K is the body's A, heat capacity, B, internal energy, C, specific heat capacity, D, latent heat of fusion. The right answer is specific heat capacity. The specific heat capacity of a substance is the heat required to raise the temperature of 1 kilogram of heat through 1 degree or 1 Kelvin. Take note of that. Question 17. The melting point of a substance is equivalent to heat. The answer is B, solidification temperature. Take note of what I'm about to say. Melting point is the temperature at which solids change to liquid when heat is applied, right? While solidification temperature is the temperature at which liquids change to solid when heat is removed. Take note of that. You can jot this down. At 0 degrees Celsius, water changes to ice block when heat is removed, but at 0 degrees Celsius, ice block changes to water when heat is applied. To question 18. Heat transfer by convection in a liquid is due to the A, latent heat of vaporization of the liquid, B, increased vibration of the molecules of the liquid about their mean position, C, variation of density of the liquid, D, expansion of the liquid as it is heated. For this question, the right answer is variation of density of the liquid. When heat is applied to liquid in a container, the molecules at the bottom of the container get heated up and become less dense or lighter than the ones at the top. As a result of this, the denser and heavier molecules goes down to the bottom, while the hotter and lighter molecule rise up, okay, to take their positions at the top. As this process continues, it creates a convection current in the liquid. All right? Now, let's take question 19. The distance between two successive crests of a wave is 15 centimeters and the velocity 300 meters per second. Calculate the frequency. Velocity, the formula for calculating velocity is frequency times wavelength. Okay, so to get the value of they ask us to calculate the frequency, make frequency the subject of the formula by dividing both sides by the wavelength. Wavelength cancels wavelength. So frequency will give us velocity divided by wavelength. What is the velocity? The velocity is 300 meters per second. Now divide this by the wavelength, which is 15 centimeters, but the unit must be the same. To change 15 centimeters to meters, you divide by 100. 1, 2, put your point here, which will give us 0.15. So you now divide this by 0.15. 300 divided by 0.15 will give us 200 hertz. Sorry, 2000, yeah. Then express this in standard form to give me, count from here, 1, 2, 3. 2.0 times 10 raised to power 3 hertz. So the right answer will be C. Question 20. A boy receives the echo of his clap reflected by a nearby hill 0.8 seconds later. How far is he from the hill? I want you to know that speed of sound in air equal to 340 meters per second. This is a constant. You need to know this. Now, to get the distance is velocity times time divided by 2. Since the velocity is always 340 meters per second times the time given is 0.8, divide what you have by 2. 340 times 0.8 divided by 2 will give us 136 meters. So the right answer is C. Thank you for staying with me and thank you for watching this video. Now, I want you to kindly subscribe to this YouTube channel if you've not done so. I'll be bringing a lot of Jamb questions that will help you prepare for your exam, which is very close. Bye.